Okay, we have written another integral. This one's from the MIT Integration Bee 2015, number 14. We have the integral of e to the 3x times arctan of e to the x dx. Okay, the first thing I notice here is just that we've got e to the x in common. This right here, we can look at this as e to the x all cubed. Now, what I want to do with this is I'm going to do an optional step and just try to clean this up with a u substitution. It's not really going to change anything. It's just going to make it so that I'm writing u instead of e to the x. So taking a derivative on this, du is just going to be e to the x dx. And then in order to make this work for this e to the x cubed, but for the substitution, in order to create this, I can write this as e to the x squared times e to the x, and then group the e to the x with the dx. So let's see how it looks when we rewrite this. So first, here for this e to the x squared, where e to the x is u, this is going to be u squared. Then we're going to have this times arctan of u. And then with this and this, we have our du. And then on this, now that we've got two functions here, what I can do is integration by parts. I'll use the di method over here to the right. I want to differentiate arctan, and then we'll just integrate this, u squared. So first, taking derivative on arctan, that's just going to be 1 over 1 plus u squared. And then here, u squared, that's just going to be u cubed over 3. So in u, part of the solution is going to be right here on the diagonal. We're going to have u cubed over 3 arctan of u. And then this part down here, this row is an integral. I can factor like minus 1/3 up front. And then what we have here is going to be u cubed. Let me write this as u squared plus 1 here, du. Now in order to deal with this without doing polynomial long division on it, I can just add a u here. That way, if you take this and you factor a u out, this is going to be u times u squared plus 1, and that's where that way we'll get cancellation with this. Now, of course, I don't want to change it, so let's also subtract off a u, so we're just adding a 0 there. But then let's take this minus u and split this off into a second integral. So here, distributing like minus 1/3 to the minus sign here, I'll have a plus 1/3 in front. We'll just have this as a u in the numerator over u squared plus 1 du. But now I think we have a couple of easy integrals here and here. I can cancel a u squared plus 1 and u squared plus 1, so we're just integrating u over here. And so here we can actually set this up really easily. If I multiply in a 2 here, then we have our derivative in the numerator of the denominator. I don't want to change it again, so let's multiply by 1/2. And now let's see if I can put everything together. So first, copying down this first part. Integrating over here, all that's left is u, so we're going to have minus 1/3. This is going to become u squared over 2 for that integral. Here, this is going to become a plus 1/6 in front. And then here, I'm actually just going to substitute on the fly. Like if you think of everything in the numerator as dt, if we did a substitution for t, this would be like our t value. So integrating this, we're going to have just natural log of u squared plus 1. Drop the absolute value because this is always positive. And then we just need to back substitute in order to finish this thing off. So what's going to happen? First, u cubed is going to be this e to the 3x that we had in the beginning. So we're going to have e 3x over 3 arctan e to the x. Multiplying minus 1/3 times 1/2, we're going to have minus 1/6 e 2x plus 1/6 natural log e 2x plus 1. Add a plus c, and that's it. Okay, there you have it. Quick problem from MIT 2015. Thanks everyone for watching. Have a good day.